Why does gravity control galaxies, yet fail to hold a single atom together? Why can a tiny refrigerator magnet effortlessly overcome the gravity of the entire Earth? The answer is not strength, it is distance. Every interaction in the universe, from the moon raising ocean tides to the binding of atomic nuclei, is governed by a single, surprisingly powerful variable: how far apart things are. The forces of nature are like dancers on a cosmic stage. Some can reach across billions of light years, others vanish within the width of an atom. Their behavior is dictated not by chance but by precise mathematical relationships with distance. And as we move from the largest structure in the universe to the smallest, a remarkable hierarchy emerges. When we examine how different forces change with distance, a striking pattern appears. The key is the exponent. The higher it is, the faster a force collapses as objects move apart, and the more violently it intensifies as they come together. This table reveals a profound truth. The universe does not use one force everywhere. Different forces dominate different scales because they fade with distance at dramatically different rates. Gravity and electromagnetism both follow the inverse square law. This relatively slow decay allows them to act across enormous distances. Gravity shapes planets, stars, galaxies, and the large-scale structure of the universe itself. Electromagnetism governs atoms, chemistry, light, electricity, and nearly everything we encounter in daily life. In fact, electromagnetism is vastly stronger than gravity. A simple refrigerator magnet can overcome the gravitational pull of the entire Earth on a paper clip. So, why does gravity rule the cosmos if it's the weaker force? The answer lies in cancellation. Electromagnetism comes in two forms: positive and negative, and most large objects contain a roughly equal amount of both. Planets, stars, and people are, on the whole, electrically neutral. Their charges cancel each other out, and so does their electromagnetic pull on the world around them. Gravity has no opposite. There's no negative mass to cancel it out. Every particle, every star, every grain of dust pulls in the same direction, always together, never against. So, while electromagnetism is far stronger at the level of individual particles, it cancels itself into near silence at large scales. Gravity, however weak, never stops adding up. The quantum glue, Casimir and van der Waals forces. As we move into the microscopic world, distance becomes far more demanding. These next two forces share a neighborhood but not an origin. The Casimir effect arises from fluctuations in the quantum vacuum itself. Even empty space exerts a subtle pressure between surfaces. Van der Waals forces, by contrast, come from fleeting electrical attractions between the shifting charge distributions of nearby atoms and molecules. Unlike gravity and electromagnetism, both forces intensify dramatically as objects approach one another, and they do so far more violently given their much steeper exponents. These interactions help molecules stick together, influence protein folding, contribute to surface adhesion, and even allow geckos to climb smooth walls. At these scales, distance acts less like a dimmer switch and more like an amplifier. Push still deeper into reality and the hierarchy changes again. Inside atomic nuclei, the strong nuclear force takes command. This force binds protons and neutrons together despite the enormous electromagnetic repulsion between positively charged protons. But unlike gravity's gentle reach across the cosmos, the strong force's grip vanishes almost as soon as you step outside the nucleus, a sharp, exponential cutoff rather than a slow fade. At distances smaller still, we leave the realm of forces altogether and meet something stranger, a rule, not a push or pull. The solidity of matter arises largely from a combination of electromagnetic interactions and the Pauli exclusion principle, which forbids identical fermions from occupying the same quantum state. When atoms are forced together, this exclusion creates an extraordinarily powerful resistance to overlap, and that resistance is why your hand never actually passes through a table, even though both are mostly empty space at the atomic level. The beauty of reality lies in this layered hierarchy. Each force rises to power exactly where the others fade. Subatomic scales, Pauli exclusion draws a hard boundary. Nuclear scales, the strong force locks nuclei together. Molecular scales, Van der Waals and Casimir forces weave atoms into structures. Human scales, Electromagnetism defines everything we touch, see, and feel. Cosmic scales, gravity shapes stars, galaxies, and the universe itself. If any of these distance relationships were slightly different, chemistry, stars, planets, or even solid matter might never have existed. The universe is not merely made of things, it is made of relationships. The most fundamental of these may be the relationship between force and distance. Distance decides not just how strong a force becomes, but which force gets to rule. Quantum exclusion at the smallest scales, gravity across the largest. In that sense, distance is the hidden architect of reality itself. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.